Hello and welcome everybody to Kubernetes online masterclass series hosted by Rancher Labs. Good morning, good afternoon, and good evening, depending on where you are joining from. We have several hundred people registered for this class, and we are expecting many of those to join from all over the world. This is a new series, still relatively new. We have done 3 of these already. The class is about an hour. It takes, and we basically put about 30 minutes of live Q&A if there is a interest and ask for that. So far we have covered many interesting topics. If you have joined us before, then you must have seen those. We did getting your hands dirty in Container Sandbox, which was around security. Today's topic is up and running with Windows Server containers. And then next time, we are again going to go back to security and talk about preventive security for Kubernetes enterprise deployment. So we cover a variety of topics. We have more coming up, like CI/CD security, how to run databases in production on Kubernetes, and more. So the question that we often get asked is, why are we doing this? Well, we talk to thousands of users every month. We go to DockerCon, KubeCon, many conferences, and we repeatedly hear common challenges that users face as they deploy and scale Kubernetes. And these challenges are common, irrespective of the industry or the company that you work for. They mostly relate to things like, how do you manage multiple clusters, how to deal with security challenges, sometimes just how to get started, how to monitor workloads. So we collect all these topics, and then we kind of also monitor the Slack. We have a Slack channel which is open to anybody who wants to join and become part of the community. I will share a link with you if you're interested in that, and we get tons of questions there as well. And then finally, we think that there are many resources for you to learn Kubernetes, and a lot of them are free. But the problem is finding the right resource and then being able to use it. That's a little bit of a challenge. So instead, we thought, if we can give you a way to learn something very quickly, show you how it works, give you enough resources to go and follow up, then you will have a good start. Like, we will all learn from each other and all get a good start. So that's the purpose of this series that we started. Okay. If you want to know more about what topics are coming up, here is a link. It's rancher.com/Kubernetes masterclasses. Like, you can go to this link, check it out, and then try them. We also get a lot of questions about just how to get started with Kubernetes. And if you want to do that, every Thursday we run another training which is aimed at complete beginners. And this is a very good topic, very good training. Only in like just an hour and a half, you get to see how Kubernetes works, how to get started, what you can do. And if you spend just 45 minutes to 1 hour in this class, you will walk away with knowing quite a bit about how to get started on Kubernetes and start talking about it as well. But today's topic, coming back to it, it's about Windows Server containers. And our speaker today is Jason Van Brackel, also known as JVB, as we all call him. He's Director of Community here at Rancher Labs. Jason is a developer, has been a developer for a very long time, solution architect as well. He has worked on a wide variety of platforms and languages and frameworks, anything that you can think of, all the way from mainframe down to microservices today. He's very well versed in Windows technology, especially .NET. And he also runs Kubernetes Philly. So if you are in Philly area and you want to check out Kubernetes meetups, then you can definitely go and check out Kubernetes Philly. And my name is Ankur Agarwal. I'm head of product management here at Rancher Labs. Basically, I end up defining new capabilities and products for our users. Prior to joining Rancher, I built and ran Kubeship.io, which was an accelerator based on container delivery. I myself have been in cloud and DevOps for about a decade, and I'm very happy to host this series for all the other users who are willing to learn and spending their time learning new technologies. So how we are going to do this is I'm going to hand it over to Jason right now. He will get started. He has a presentation and then some demos. And then meanwhile, if you have any questions, and no matter what they are, feel free to shoot it to us. We believe every question is worth answering, and sometimes we get questions like, how should I talk about Kubernetes to my manager? What can Kubernetes do? How are Rancher and Kubernetes different? And that's all fine. We are happy to answer all the questions that you have. There are no bad questions, but we do get hundreds of questions sometimes, so we try to answer as much as possible, and then we stay back at the end. If you are still interested, we'll keep answering more questions. Okay, with that, one final word. We get a lot of questions about, is this session being recorded? Yes, it is, and a link will be sent out to you, or you can come and check us out on our YouTube channel and find this as well as many other sessions that we have done. All right, with that, JVB, it's all yours.
All right, then I will change myself to presenter and I will show my screen. And can you see my slide deck?
Yes, we can.
Awesome. So welcome to Up and Running with Windows Server Containers. As Ankur said, I'm JVB. I'm out on Twitter, Jason Van Brackel. I'm out on LinkedIn. Feel free to add me if you have any questions and you're not a Twitter person. Just let me know that you heard me here, so I know you're not LinkedIn spam. I get a lot of that. I'm also out on the Rancher and Kubernetes Slacks. I'm at JVB there as well. The slides that you see from here on out are available in source code with all the links and resources. So if you want to go back to something as well, that'll be available as we walk through this. So today, we're going to demonstrate the current capabilities of Windows container support in Rancher. We'll also review the Docker architecture in Windows because it's different than Linux. We'll discuss some limitations of container support both in Rancher and in Kubernetes, and the pathway for Kubernetes going for Windows container support in GA. And then we might touch a little bit on the Rancher Terraform provider. This is something new we're creating for DevOps teams that will allow you to integrate Terraform with your Rancher platform and actually create Rancher components on the fly. So that the demo today, I used both of those and wanted to make sure to highlight that as well. So first things first, we need to spin up Rancher. We need to have some Terraform, and we need some Linux and Windows Server nodes. So if you're interested today, everything that you see here is up on my GitHub. So if you go to github.com, and go to Jason Van Brackel, which is me. I have a repository here that I've been working in for the last few days called Kubernetes Windows Server Container Masterclass. As you can see here, just minutes ago, I was making changes to this. So I had some ideas around, what could I do here that I could give out to the community? And I decided to make sure that all the things I demoed today were available. There's lots of caveats and warnings in here because this is an experimental feature. The Kubernetes support for Windows Server Containers is still pre-GA. It's in beta right now. They're hoping to be GA by 1.14. That may or may not happen. A lot of things that needed to happen have happened, but there's still code that needs to be written to get that into 1.14 before the end of month code freeze. Might be March 7th, I believe. So a couple prerequisites. You'll need Terraform. For some of the items in here, you'll need our provider. Instructions are here. And you also need an Azure AD Service Principal. This specific demo I did in Azure because it is Microsoft oriented. I figured why not just do everything Microsoft in this case, and then some instructions about running it. If you're not familiar with Terraform, check out Terraform.io. It is a product created by HashiCorp specific for automated provisioning of IaaS, automated provisioning of components, and even in our case, automated provisioning of Rancher items. But first things first, we did a Rancher server. So one of these screens I have. So what I've already done is I've already set up a DNS entry for my server, set up a VM ahead of time, installed Docker so that I'm ready to go. And then it's just a matter of launching a console and launching a Docker container. So you see I had it already pre-written here. This is consistent with starting up a single node instance Rancher server. If you were to go out to our documentation, it's just docs.rancher.com to the Rancher 2x to installation and to single node install. So this is consistent with what I'm doing here. I have no front-end load balancer in front of it, nothing like that. So that's probably already up and running. Now, I could have done this with a full cert chain via Let's Encrypt. I didn't. And we've hit one of the first caveats of working with Windows Server containers in Rancher. There is some code in Rancher which checks for a CA checksum as part of the authentication process to Rancher and to Kubernetes. It's actually a little bit of a bug. It assumes you're always going to have one. But if I have a proper CA cert chain via a public certification authority, I shouldn't need that. But it's required right now by the call. So I had to basically turn off my full cert chain, use a self-signed cert chain generated by Rancher for this to work. So that's one of the first caveats you'll run into. So I'm going to proceed, even though it's potentially unsafe. It's my server. I know it's safe-ish. It's mine, after all. And I'm going to create a new password. I promise it will not be 12345. Probably like password or something. Oh, and they should match. That kind of helps. There we go. So I have my new admin user. I have to create a server URL for those who are unfamiliar with Rancher. This can't change. It has to, once you create it, it has to be accessible by the Kubernetes clusters that you create or import, and then it cannot change. So now we have a fresh and running cluster here. And ready to go. So one of the first things that I'll need is I will need a way to talk to this Rancher server from my Terraform provider. So I'm going to create an API key. And so Rancher, like anything else, has a REST API. Also has a CLI that talks to the REST API, has a UI that talks to the REST API. So everything can be automated through the REST API. So our Terraform provider uses that REST API, and I'll need a key, and I'll create one. Now you're going to get to see keys and stuff today. Please don't do evil things during the demo. That would just ruin everybody's enjoyment. But I want you to actually see how this is put together and how this works. So I'm going to copy this token, and then we'll open up Terraform. And I'm going to need much larger fonts for this because I'm sharing with the world. Ankur, how's that look? Is that readable?
Yes, it is.
Okay, good.
I can definitely see it.
Okay, so as you can see here, I have this manual. There's a manual setup, which will be for creating some nodes. We'll do that. The slide deck is already in here in a PDF, if you'd like to look at that. And in here, we have the main of Terraform. So in Terraform, you have these TF files that define how things are laid out. And we're just going to adjust some of the variables in here. So it's described pretty well, both in the Terraform documentation. I've given you some bits and pieces here for things that you could use as an example. But right here, so I already got my Azure Service Principal laid out. I did that ahead of time. We need to put our full API token in here so we can talk to Rancher. And I'm going to set up two separate instances here. I'm going to set up one using the Terraform provider, and then another manual setup, essentially just bootstrapping the nodes to do a by hand manual UI process. So I'm going to get both of these up and running right now. So I'm going to pop open a script here, go into my manual setup. Yep, everything looks good here. I'm going to do a Terraform apply. And it's going to tell me that I have to fix because deprecated, which I'll do later and upload this to the script so you have it. And this is going to create a whole bunch of nodes on my behalf. Now, I've told this to create essentially one of each type of node that I need for Kubernetes, my workers, my etcd, my control plane, and also a Windows worker. So if you look for the Terraform, if you're familiar with Terraform, you'll see Linux nodes getting set up, Windows nodes getting set up. And this is just telling me all the things it's going to create on my behalf while we talk about architecture. So 23 items that we won't have to wait for, and this will spin up and start running. Additionally, I'm going to do the easy bake method as well. Ooh, you can't read that. So let's make that about 28. And here I am. Okay. Now, one thing about this is I've worked with this in Linux and in Windows. It's a little flaky in Linux and Mac OS because the way WinRM, which is Windows Remote Management, works in Mac OS and Linux. So your mileage may vary. Feel free to hit me up with questions on Slack, on Twitter, on LinkedIn afterwards. If you start experimenting with this and have some issues, I've played with it in both. I have a Mac machine sitting over here, sitting to my right. I have the Windows machine I'm on. I have the Linux machine to my left. So I've played around with this in all three, and I've seen the caveats with them. So just know you might see some caveats. And again, we'll do a Terraform apply here. And this will be a different set. So right now, one of the restrictions here is that we have various workflows in Rancher. Essentially, through the UI, you can only use the custom workflow to work with Windows Server containers right now. I'm cheating a little bit by using the Terraform provider, because the Terraform provider will actually let me spin up Azure nodes in an Azure cluster via Docker machine and doing it that way. And then I'm creating a separate Windows Server container that gets added later. So we're going to let that run as well. And that will also instantly start changing my Rancher management server. So I go into here to Rancher, and I go to cluster. It's actually already spinning up a cluster on my behalf via that the custom provider. So as I mentioned before, just so you see it visually, what is going on right now is I'm creating nodes that will be used in a custom workflow right now, and that's the 23 nodes during that first run. The second run was using essentially this provider here. I'm just automating the use of this provider, and then after the fact, after that's already up, I'm going to use the fact that the Terraform provider gives me inside information the UI doesn't give me into the API to add a node after the fact. And we'll have a little bit of a workaround here because I'm using smaller Azure nodes. I'm using D2v2s, and D2v2s do not allow for nested virtualization. So our call out to Docker wants to use nested virtualization, and it can't. So I'm going to manually massage some things, but it also helps because then we can see under the covers a little bit. But now that all of our automation is running, and that'll take a few minutes, we can now dive back into our slides because we've got Terraform running. We've got some servers coming up, Linux and Windows. So let's move on. Source material. All the diagrams you see here were created in this talk. I took screenshots from this talk. I've been using this source material for a number of years now. It's the DockerCon 2016 talk on Windows Server and Docker, internals behind bringing Docker and containers to Windows. It's Black Belt talk. It's a great talk. This talk is worth your time. You can open the PDF and watch this talk. Just do it after we're talking now, so you pay attention. But first, let's talk about architecture in Linux. And if you've looked at Linux Docker architecture, this should look familiar. And we're talking specifically about Docker. So we're not talking about Cryo or Kata containers and the other technologies you can plug into Kubernetes. This is specific to Docker. So our clients on the top, our Docker client, our Docker Compose, our registries and Swarm. Docker engine in the middle there, which has libcontainerd and libnetwork. And then that layer in between that containerd and runc that we're also familiar with that had the vulnerability last week that everybody had to plug, Docker included. And then the operating system constructs, your C groups, your namespaces, your file system layering, and your other OS functionality that all of your Docker containers are sharing within the host operating system. This changes in the Windows world. Because we don't have this concept of runc and containerd in the Windows world. We have this compute service, and this compute service is owned by Microsoft. It's not open source. It was created as a collaboration between Microsoft and Docker. And then we've created stand-ins for C groups, stand-ins for Linux namespaces, and stand-ins for layering. So C groups, at least from a Windows perspective, are job objects. And if you've been a Windows developer for any length of time into the Win32 SDK, you know what a job object is, because job objects are a low-level SDK construct in Windows that's specific to running processes and isolating processes. So that was thing one that Microsoft and Docker had to create together so that Windows could do Docker. Thing two was namespaces. They don't call them namespaces, at least in the video. They refer to the namespaces. They also refer to them as silos. So in the Windows world, when the kernel looks at your file system in a pre-Docker world, it would see /DOS devices /C / all your stuff on C is how it would look at the file system. For example, in a siloed world, it would be /silos /big crazy GUID /DOS devices /C and / all your stuff. So they've added layers into the Windows kernel that allow for you to have containers in Windows. These were major changes to the Windows operating system. They continue to change the Windows operating system. to make it more Linux-like to support these container paradigms. So every version of Windows has stepped a little bit further in order to support a more native feeling container paradigm. And then layering capabilities, because face it, NTFS is nothing like any of the file systems in a Linux world. It's not a true union file system, and by union file system, all I mean is when I do a DF in Linux and I see all of my mounts there and all my disks, I see that file system as one thing. NTFS doesn't work that way. I don't really, when I mount a network drive, I see that as a separate network drive. It doesn't feel the same way as it does in a Linux world. It feels very Windowsy. So they've had to create a union-like file system extension to all the things in Windows for this to work, and it gets a little better each version. So Windows Server containers looks a lot like anything you would see in a container model for for Linux, except it's just Windows. So your job objects, your namespaces, your storage registry, they all have individual hooks into the Windows kernel, and they sit side by side in user space. Now, so this would be very similar. This would be process level isolation, just like you have in a Linux world. Now, Windows Server containers throw another curveball at you, and they're called Hyper-V containers. Conceptually, from a developer standpoint, from a user standpoint, they work exactly like a Windows Server container proper. The only difference is there's this really small virtual machine that's created that's optimized to run inside a container. So essentially what happens when you call it for the first time, it spins up into memory and then just gets cloned over and over again. It's not meant to stick around very long. It's learning specifically for the age of the Hyper-V container, and then it goes away. So it's not like your VMs that stick around forever and ever, like in your Hyper-V world or your VMware world. The idea is that this is creating a sandbox for your process. This would be similar in the Linux world to what you do with Kata containers, for example, where you have a container modeled VM spinning up by Kubernetes to do that. So Docker, so Windows Server Container supports both. And really the big difference from an operations perspective is that your server needs to be able to support. If it's a virtual machine, you need to support nested virtualization, which is one of the issues I ran into as I was doing this demo. Also, the price. Windows Server containers without the Hyper-V isolation, you essentially get unlimited of them. On a standard license as of last year, the year before when I last looked at it, you got one Hyper-V container, and if you want to unlimited Hyper-V containers, you were paying for something along the lines of an enterprise or data center edition, which is significantly more expensive per core. But that's just so you know the difference as you run into this in the field. Understand that from a developer standpoint, there really is no big change there. So a couple gotchas. One is version compatibility. So because they've had to modify Windows operating system, every new version of the Windows operating system gets slightly better at doing containers, at doing isolation. But your support model gets a little bit more complicated because essentially your container images are versioned by the container OS that they were created with. So your early 14.393, which was your first Windows server, if you had your container OS was that same one, you get process level isolation and Hyper-V. But anything newer, you only get Hyper-V isolation because it hasn't been create. This is run inside of a virtual machine essentially, because all these new versions of Windows Server can support the old image, but only isolated inside of a micro VM. So I can't take my 14.393 image and just run it in process level isolation in Windows 10 1809 or Windows Server 2019 or Windows 10 1803. So this means if you want process level isolation for your containers, you're going to have to basically create, do container builds for each version of Windows Server you expect to support. For example, one of the other, we've run into the second caveat of the Rancher experimental feature is it requires that you use Windows Server 1803. It can run on later if you're using Hyper-V isolation. I did 1803 because I'm using a smaller VM, so I can't do nested virtualization. So I'm actually going to jump in by hand because we're going to run into an error during the install process, and we'll see that during my automations portion.
Hey,
So sure.
quick question. There are a lot of questions coming in, so I think
Okay.
if you don't mind, I'll ask them now. So one is about correct version of Windows OS. It seems like the gentleman tried to install one node of Windows and it did not work. So I think there is some question about which Windows version support containers, and you just showed the matrix. So if you could
Yep.
repeat it, that'll be great.
Absolutely. So for our experimental support, you're going to want to be in 1803 or later. And if it's or later, so our container OS version is 1803, which means that if you're anything before 1803, it's not going to work at all. It's not supported. If it's newer than 1803, like a Windows 10 1809 or a Windows Server 2019, it will only work in Hyper-V isolation, which means that you'll need to enable Hyper-V and make sure that's running before you install. Otherwise, you're going to get all kinds of fun errors.
Okay. What advantages do Windows containers give me that Linux containers cannot? So what's the advantage of Windows versus Linux containers?
You can run Windows workloads that are not .NET Core. So if you're looking to standardize your deployment scenario through containerization, regardless of operating system, and you're looking to move things that were written in .NET Framework, that were written in ASP Classic, that are web fronted VB6. I hope not, but there is some of that out there. I wrote some of it. It's probably still alive. Um, that's where the advantages come in. If you're just doing .NET Core, that's native to Linux. But if you need some of those those .NET Framework features, things like WCF, for example, that don't have a Linux version or a .NET Core version, that's where your advantages come in. This is really just bringing more operating systems into the fold to Kubernetes.
Okay. And this is an interesting one. Is it possible to have HA ranchers set up with Linux and deploy Windows containers? Or do I need to somehow add a Windows VM to the HA cluster and then I will be able to deploy Windows containers?
So the managed cluster that you create will have to have some Windows nodes. You cannot run Windows server containers inside of a Linux machine. That's the other thing is you'll notice all of these in the version matrix are all versions of Windows. So there is no concept of a Windows server container running on a Linux operating system. Now, Linux containers will be running native in Windows soonish. And there's a whole area about that right here. You see, it's a pretty recent article, and all the diagrams are still pretty rough. This is something that's still in development. But it's very clear from the direction Microsoft's going that they want you to be able to run your containers in Windows regardless of operating system.
Okay.
Now one caveat there. That being said, there is no such thing as a Windows master node or a Windows etcd node. Those things don't exist.
Okay. So then I think the curiosity here and the question here is, what is the status of Kubernetes support for Windows?
We will get to that. Good question.
Oh, good.
All right. All right. So the other gotcha is networking. So the networking stack in Windows has changed as well. So there were no SDNs on day one. Everything had to be manual route updates, which was a pain. So now there are two methods, and the documentation getting them up and running is a little iffy. So if I go to SIG Windows, this is a special interest group responsible for this feature. There's essentially two accepted methods right now for doing so. One is OVS OVN, which has been working for a couple of years now, and the other is host gateway networking, which is the method that we use because we're trying to keep flannel and flannel. So we're using flannel host gateway. OVS OVN is the more popular one because it's just a little bit more stable. It's a little bit older. But the issue here with documentation, for example, if I go into this getting started guide, and I start running through it, I'm very quickly going to run into an issue because this was dated and updated and dated and updated. So always make sure you're not just reading the articles as you go through, but you're also checking out the comments, because this had to be updated recently because back in August it stopped working. because I was actually running through this about this time period, and it was not working. So the documentation, because this is a newer area in Kubernetes, you know, isn't quite up to stuff with the rest of Kubernetes because it hasn't hit GA yet. And some of the automated testing isn't quite there yet. And what I recommend is get familiar with SIG Windows. Get to know the SIG Windows people. I'm out there. One of the one of the co-chairs, Michael, he and I go back. He's with VMware now. We were both at Apprenda together. Apprenda has since dissolved, and the assets sold. But a lot of the early SIG Windows stuff came as collaboration between Apprenda and Microsoft and Red Hat and Pivotal, and a lot of those companies are still involved in SIG Windows in varying capacities. So I would highly recommend getting on the Kubernetes Slack. Which I'm not sure if they're accepting if they're accepting new people right now or not, but then going up to SIG Windows. So SIG Windows, there's a lot of us out here all the time. I was asking questions this morning, and it's just the SIG Windows here. And again, I'm at JVB out there as well. So that's the other thing. It's documentation and the networking layer are the other gotchas with working with this. So keep in mind, from a Rancher perspective, it's experimental support. It's the custom workflow only, unless you cheat and use the Terraform provider. The Terraform provider was not available when we released experimental support initially, and I actually proved out some things with the Terraform provider we thought we could do, weren't sure about it, and I did that as part of this, and I'll discuss that a little bit. And again, as far as we use Flannel networking, it's VXLAN on Windows, host GW, or VXLAN on Linux, host GW on Windows. The VXLAN support for Windows is either recently in master or I don't know if it's been released yet. As of the last time I checked, which was only a month or so ago, all the code changes were done in the master that hadn't been released around it yet. So that's the other thing. And then road to GA. So if you want to keep up to date what's going on, I've added links to SIG Windows as well as to the Slack channel, the Windows support KEPs or Kubernetes enhancement proposals. These have been accepted for Windows Node support. The ones around SIG Windows, and now it's just a matter of code. So I spoke to Michael yesterday just to confirm that my head was on straight about where things were. The KEPs are accepted. They've passed the SIG node hurdle because there are other SIGs that have to approve this. There are some code changes that are going on actively, and the code freeze, I believe, is March 7th. So there are a number of developers for Microsoft and Pivotal and other community members that are involved in this that are actively working on code to get Kubernetes to GA. So the plan is, it should be GA in 1.14. If it doesn't hit 1.14, I would be very surprised if it wasn't in 1.15. And then as far as us going GA with our product, it really is a matter of first thing first, Kubernetes being Windows GA, and then us integrating VXLAN for Flannel and a few other things that have to happen. Be able to support multiple operating system versions besides just 18.03. And then I've added resources, links for everything. The Microsoft documentation around virtualization, the GitHub for today's demo, the talk that I spoke about earlier that had the earlier link, my Twitter, my LinkedIn, and my 2 Slack links, both the Kubernetes Slack and the Rancher Slack. If you join the Rancher Slack, you'll likely get a direct message from me. It's not automated. It really is me copying and pasting something that I've authored to help you to introduce myself and to the community, welcome you to the community. So if you're looking for help, our community is awesome. I can't say enough really good things about our community users, our open source users, companies that have purchased support contracts that are involved in the community. I can't say more great things about them. They're really great people. But if you run into a roadblock, hit me up because I have access to the Rancher team that might know something that they don't. And then my personal blog at the bottom, More Human Software. Everything that I do, whether it's Rancher related or not, ends up there. So that being said, it's time to see how our demos are doing. So we have our cluster. Our cluster is up. It only has one node right now, and that was what I was fully expecting. So I created a dual control plane etcd node just for, it costs me less and it spins up faster. And then I spun up a bunch of custom nodes. Let's see how those came up, make sure we can run into any errors. So we can see here. So what happened in this one, this is the one that has the error because of I stood up, that stood up that Windows, that Kubernetes cluster. It stood up the Rancher node. It went to tell the Rancher node to join. It pulled the actual Rancher agent, did everything it needed to do, and then ran into an error because it says no hypervisors present. This is an okay error if you're running in a VM that does not support nested virtualization. You need larger Azure VMs to support nested virtualization. I think it starts at like D3s, which are sizable nodes. I'm doing my demo on something smaller, but I wanted this to fail anyway so I could show you what's going on under the covers by jumping into that server. So that did everything we expected to do. And then, did it come up? Okay, let's do this again. So there was an issue with Terraform output of items. Did I get nodes? I think I have nodes. I should have nodes. I see no errors. So let's do this one more time. So there's an issue with the Azure provider for Terraform where it doesn't always spit up your public IP addresses. And it might be because I'm using the deprecated method of saying it's public. Might also just be because of the same issue I ran into a year ago when I started doing these scripts. And essentially I had to run double output to get it to spit out anything of value. And and there it goes. So now I have my control plane node and a TD node, a Windows node, and a worker node. They're not running any of those things yet. I've just separated them via my Terraform script. So again, going into my manual setup, my Terraform script, I have all kinds of stuff around here about setting up disks and setting up network security groups that all ended up in Azure. So if I go into Azure now, I should have all kinds of cool stuff up and running. So let's launch into this. So we'll get the easy one up first, and then we'll do the harder ones. The easy one is the one that is pretty much 3/4 of the way up. So the second Terraform I wrote that only had 10 items is what spun up. Let's see, it's this window. Now let's close these down. We don't need all these. Is what spun up this environment here. So I basically added another node that can register in here. So one of the things that we don't expose in our UI yet is so every Kubernetes platform we create has a key available to it where you can add more nodes to it. And it's how we use our custom workflow. But because it's created with RKE or the Rancher Kubernetes engine, even the ones that are created via this path through the Azure workflow, if I were to go back to give you context, add cluster and Azure. So these actually have a key because they're created with RKE and Rancher Kubernetes engine. So I have another node up and running for that, and let's jump into that node and actually just finish what it started. So yeah, if you're using smaller nodes, you're gonna have to do this as well. So pay attention. I'm gonna go into my resource groups, and I created the manual setup one and the Rancher group one. So we're going to the Rancher group, which already has a running Kubernetes cluster in it. Single node control plane etcd, and then my worker node, which has not joined yet. So I'm going to jump into my worker node, and this is a Windows node. It's running Windows Server 1803. I believe it's the Nano Server version, so it doesn't have the whole full GUI, which is fine. We don't need the whole full GUI to do what we're going to do. And I'm going to download the RDP file, and let's launch this. And no, it's not that account. I need a different account because I manually gave it credentials. And let's see if I can type in this password. And then it's because Azure wants you to have a 12-character password or more. And you know what? I'm just going to go grab it from my Terraform variables. Like I said, you're seeing passwords here. Please be nice and not muck with my demo while I'm demoing. Oh, what did I do wrong? Oh, these are the manual ones. No, it's the manual ones. That's manual setup. This is problem. I got two of them. So Jason Brackel, and it must be a slight difference in the passwords. Oh, I closed it down. Let's go back to here and connect and download. Oh, we'll just re-download it. That's fine. Yes, connect. And then more choices and use a different account. And did spell my name right this time. Yay! There must be a slight difference in the password I use on the manual versus the other. So I'm in my Windows prompt. I should have Docker available to me. I do. I don't have Hyper-V because this is a smaller Windows server, so I couldn't do nested virtualization. So what I'm going to do, since we use Terraform, is Terraform saves the state of everything, including a really cool key called Windows node command. So we can actually add a Windows node to any RKE-backed platform. We're going to grab that. We're going to massage it a little bit to take out any special encoding. So I'm going to take that out. I don't need this. There's my special super secret RKE key to add this and the checksum that it requires, which is why I use the self-signed certs that I mentioned earlier. My server, you can see here my nano server 1803 tag. And I'm going to take out the Hyper-V isolation because I can't use that here, and which is why this whole thing failed. If you're using this on-prem or you're using this in larger Azure nodes, it should work without having to do all of this massaging. So I'm going to just grab everything from Docker run on. I'm going to just paste this right in here. And I'm going to proofread it to make sure everything's working here. Token, checksum, looks good. So what this is doing now is this is going to pull down the Rancher agent container if it doesn't already have it. Then it's going to launch. Oh, that's weird. I expected it to do more. Is it doing something and I just missed it? No, it's not doing anything. Docker run host server token. Okay, let's try this again.
Jason, while
Yes.
you are bringing it up, let me ask you a question.
Sure thing.
Is using Windows containers a little bit more tricky than just using regular Linux containers?
It is absolutely more tricky. So, one just because getting support is harder, and two, it's getting support is harder, and two, it's it's not as documented and things of that nature. Let me just grab the whole command here. Also, you have to make sure that you use your node annotations you have to use your node annotations to make sure that items end up on the proper nodes because not everything has both a Windows and a Linux version.
So would you say that the technology is new and under development, or are you saying this is a technology that will take several years to mature?
It is definitely, oh, I know what I did wrong. It is definitely a new technology. I don't think it's going to take several years to mature because it's been maturing for several years. But V1 is still going to feel a little hairy, just from the nature of how these things work. And I think I just figured out what I did is I was not in PowerShell, and because this needs to run from PowerShell. Yeah, that was probably my fault. So yeah, that's just it. It's just it is a newer area of Kubernetes that is just it's maturing. Yes, that was my problem. Pardon the live demo. I wasn't in PowerShell to run that. Didn't run my PowerShell command. So that should now be. This will take a few minutes to run because it's going to do a whole bunch of different things. So it is going to download the Rancher agent, and you can see here now it's already pulled the Rancher agent. Cool. So the container has started up, and this is all the logs coming from the Rancher agent now. So it's downloading it's downloading Kubelet and kubeproxy for Windows. It's also going to download components for Flannel, as well as components for proxy and Nginx proxy. So this will take a few minutes to start up. We'll let it do its thing. We'll talk about the manual version of this moment while that's going. Into the questions. Good time for questions.
We have a lot of questions, so let me just run through them quickly.
Sure.
Is it possible to access USB devices, serial ports, and PCI Express devices from inside a Windows container?
If it's in process mode isolation, I can't see why not, because from an operating system perspective, it's just a Windows operating system. The thing is, you'll need to be able to do everything from the command line. So, in a Linux world, you're used to seeing containers where you're doing apt-get to install things that you need. In a Windows container world, I would highly recommend, if you're not already familiar, is Chocolatey.
Okay.
So if you look at most of the ones that I've developed over the years, they're using Chocolatey, which is a package manager for Windows that will then do all the similar to Yum or to apt-get in the Linux world.
Okay. Is it possible to migrate .NET to .NET Core? If yes, are there tools that can help with this?
That's one of those big maybes, because .NET Framework. .NET Framework is a superset of .NET Standard. You know what? This will work through a diagram. So let me look at .NET Standard. So yeah, so .NET Standard is what all of the .NET implementations do, whether it's Mono or Xamarin or WinPhone or Unity or .NET Core. They all support a certain set of .NET Standard. And this is libraries that all of the .NETs support. It's our table. Let's see if there's an interactive table. There we go. So depending on the version of or the libraries you use, so you have not just the core not just .NET Standard, which is supported by all of these. You have each one of these is also a superset. So Framework has things like WCF and WPF that aren't in .NET Standard. Or maybe WPF is. I can't remember off the top of my head, but I know WCF isn't. So the short version is maybe. It really depends on how big. So microservices come over easier, but things that are not, things that are big monolithic applications don't go to .NET Core very easily. That's the short version of the answer.
Okay, cool. Let me see if there are any other ones. Do you recommend using Windows Dock for performance?
Windows Dock?
Yeah, I didn't know if this is something special in Windows, but
I'm not familiar with that.
No worries. Let's move.
All right, so moving on. I had those other nodes I created, and this is the workflow that worked before the Terraform providers. I go into custom, and I create a custom cluster, and I would set my members up. That's all our RBAC stuff. Don't worry about that. And I go to my cluster options, and I want Windows support. So I need to use Flannel because Calico and Canal do not work for that. And I'm going to grab where is my? I should have my Windows support lighting up. Is it 10? No. 12? Let's try this again. Okay. Why is my Windows support not launching?
As you are going through it, a bunch of people are trying to point out that you probably used the wrong username and some of the things like that.
Custom works just fine. Custom. I am an admin, right? Yep, I'm default admin. I should do that just fine. Member role, default admin, cluster options. Okay. UI glitch. So enable Windows support. We set our options. And so now what my automation was doing for me earlier that I logged in, I have to do for each node by hand. So I'm going to go into my Linux nodes and I'll start my worker node. And I'm going to launch my privileged Docker command, go into my Docker portal, go over to my other resource group, go to my manual resource group. Which one did I just grab? Did I grab worker? I think I grabbed worker. I grabbed worker, good. So I'm going to grab the worker and log into my worker here. We're going to connect via SSH. So I need to connect and SSH. And then we will SSH. Oops. Don't need two SSHs. And yes. And I'm in because I set it up to use my SSH key that's already installed onto this machine. And so I'm going to now grab my Docker command again, right here for my worker and spin that right up. Oh, I'm not a smart guy. I forgot to install Docker on these. That's what I forgot. So apt install Docker. Oops, sudo. And we'll let that do its thing. We'll just open up a bunch of these because we're going to need a bunch of them. So I need a bunch of PowerShell windows. Let's see, that's etcd, and that's control plane, and that's my Windows accidentally for my Windows node because I have to come in via RDP or WinRM. That's the other thing of note. As you're working with this, keep in mind this is not a production ready demo. There are some things that are insecure about how I set up this demo. For example, I left WinRM wide open, which is a big no-no. And there are better ways to secure than that. But for the sake of a demo, for you all getting started, it's good enough. So I'm going to grab that. We'll grab one of these other windows. Oops, wrong window. Grab another one of these PowerShell windows over here. SSH into the etcd node. Yes. Sudo apt install Docker. All right, so that's doing its thing, and then we'll do it here for the other node. I already grabbed the worker. I grabbed the etcd. Let me grab the control plane node, and we'll connect. Grab my SSH for this, and let's grab the other empty one. Again, yes. Sudo apt install Docker. And then let's go back to that first one. Not that one. This one. And Docker, so I should be able to do a sudo docker ps, setting up Docker. Oh. Okay, I did something wrong. Is it Docker IO? Oh, I forgot to say yes earlier. Helps when you say yes. And IO, yes. So the fun of live demoing. And I'm just I can remove that one because we don't need to look at that right now. And then sudo docker ps. There we go. So we want a worker node, a control plane node, and a etcd node. So I'm going back into my rancher. I'm going to grab my worker node, That's gonna go ahead and pull that. Let's do the same thing with my control plane node. Go in Rancher, grab my control plane. You notice I can have multifunction nodes. Install that. And then go back one more time, grab my etcd node, and install that. So what's happening now is it's doing a Docker run of that Rancher agent, just like on the Windows Server earlier, and then calling home into that. And it's going ahead and installing the Hyper-V container, which is the community run container that has all of the Kubernetes binaries in it that launch differently by argument. So as those get registered, I should see that I have nodes registered. So those are all done. And now let's get the Windows node going. Grab my Windows worker, and then it'll be very similar. I might need to massage it. Well, that's funny. The command that came from earlier had the hypervisor. This one, or it had the Hyper-V isolation. This one doesn't. So maybe it's a bug in the Terraform provider, not in my actual demo. So now we can connect to that last cluster. So we go into our We go into our virtual machines. We'll connect into our manual setup one, and we want the Windows worker that was created as well with that set of nodes. Now this one we can't SSH into. One of the other things I want to do with this demo is add OpenSSH in the SSH daemon so that I can have a unified way of doing this, because WinRM is a royal pain, especially in the cloud and with Linux, and OpenSSH just works everywhere. So I'm going to connect with that. I'm going to download the RDP file, launch this as the Windows node, which will look remarkably like the other Windows node because they use the same Terraform setup with a slightly different password setup that I will have to check because it was different than the one I copied earlier. And I'll go to my manual setup and my variables. Nope, that's not the one I want. I want the actual TFRs. Grab that password, copy, and paste. And OK. Oh, what did I do wrong? Different account. Oh, are these the, sorry, that's the JVB ones. That's what I did wrong. Wrong username. Thank you all who were telling me this wrong username earlier, and I wasn't paying attention. And then we'll go grab, since I did copy and paste that, I'll re-grab this, copy, and paste. Oops, yeah, that should work. I did give it the PowerShell pre-command, Docker run. That all looks just about normal, and it will do its thing. So what is happening there that already happened on the other server, which is one of the reasons I did it in that order. Don't want this one. Oh, here. So what happened was, we can scroll all the way up and see what happened, is that we had that run command. It went down and downloaded a bunch of stuff besides that agent, including the Azure CLI and Flannel and Hypercube. And once all those things were up and ready, there's the Nano server, Hypercube Nano server, because it needed that as well. And then it just spun up the cloud provider config, the Flannel config, the CNI, and was then waiting for the HNS network, which is the connector in Windows for that to work. So now I will, that will get a fourth once the Windows node is up. You can see the custom is still doing its thing. The Windows cluster is up, and I have 2 nodes now. I have the node pool, which is our standard created thing for that. And I have this worker node here. And like I said, here's the big caveat. When you install things to the Windows nodes, they have to be Windows Server container images, and you have to tell them where to go. So they have to be able to go to a node with the proper operating systems. If I expand all of these and we look at the annotations and the labels, we can see here we have operating system Windows in the system information, and also in the labels we have this beta Kubernetes iOS of Windows, which we'll have to use, and then all of the information around all the annotations for Flannel and RKE as well, and then the node taints. This is the really important one. You have to create tolerances for this specific key value pair. So let me see if I can grab an example. So I will do a Windows Server.
Jason, just to
Yes.
give you a time check, we are only a minute or 2 away from wrapping up.
All right. So I will try to deploy one thing since that one is up and running. And if it doesn't work, we can just stop there.
Okay. And we have a bunch of questions that.
All right. Where's my, give me some test YAML. I just want some test YAML. There we go. Scheduling pods on Windows. So I want this one here, which should work. Now, I don't need this to work. I needed the 1803 one, but I bet there's an 1803 tag. So if I were to go into here and I need that node selector on, I need tolerance for iOS Windows. So when I go into here and actually go to deploy something, you know what? I'm just gonna straight copy that and dump it in with YAML, because just for the sake of time. So I'm gonna go and grab this simple pod. And I may run into an issue because I'm not sure if there's an 1803 version of this, but we'll give it a go anyway. And if I go into my cluster here, and I hit my default, and I want to import some YAML, That's fine. Oops, helps when I paste it in there. We're just going to assume there's an 1803. There may not be. And then I have a node selector around that, and I do need a tolerance as well, I believe, but we'll try importing that and see what happens, and it may just be unschedulable. Unavailable, and let's see what it's doing from a event standpoint. So you can see and look at the events and see containers on ready status, container on ready status. Yeah, it's probably because container creating. Look at that, it's actually doing a thing. If I jump into one of these Windows Server nodes, I'm not sure if it'll spit anything or not. It may not, but we'll let that run and see if any events pop up while it's doing a container creating. It may or may not run, and I'm okay with that. Questions?
All right, we have a ton of that, and
Awesome.
you would like to look at those, you could also turn on your questions.
Oh, good.
So you could choose some of those. But there are some interesting ones. Do you envision any ingress solutions for Windows, or do you see ingress always require multi-OS worker nodes?
I think as this matures, there will be a Windows ingress. Maybe not a Windows Nginx, but there's already some work being done around traffic proxies for Windows and reverse proxies and using it as an ingress. So yes. The short version is yes. This just needs to go GA first. That's really what needs to happen beforehand.
Okay. This will be an interesting one for anybody who needs a highly secure environment. Is air-gapped install possible with the Windows Rancher agent?
Yes, it would only require that you would have the Rancher agent with the specific tag around Nano Server in your image repository. Because the image format is the same regardless of where the image comes from, whether it's a Windows image or a Linux image, it can go in the same air-gapped image repository as all the other Docker stuff that you have.
Okay. To run a Hyper-V container, do I need Flannel? What is the easiest way to get a Hyper-V isolated container to talk to its host?
So to have a Hyper-V container up and running, yes, you'll want a network overlay like Flannel or OVS OVN. I would invite you, if you're going to set it up, if you're not going to use our experimental feature and actually set it up by hand. Oh, it is running. Look at that, already up and running. So if you are going to set that up by hand, what I recommend is actually going out to the SIG Windows link in the that is in the PowerPoint presentation down here on the resources, and look at where is that? Wrong slide. The SIG Windows information specifically around networking with either OVS OVN or Flannel, which is in here. Like I said, as our stuff goes GA, we'll have all of that done in an automatic manner, much like what you see with these ones that are already up and running now. Another question?
Yeah.
All right.
Is the registry image working in Linux able to store Microsoft images? If no, is there any alternative?
Yes. So I think I mentioned that in the earlier question. The Docker image format is the same regardless of how that image was created. It really is just a matter of making sure, like in an air-gap scenario, that you have all the images. Let's try this one more with it, see if I can get a deployment running. Next question.
Yeah. There was a question about CI/CD. And basically, it's like, how does a deployment CI/CD pipeline workflow look with this setup? So I think with Windows and does anything change, or is it similar?
It is incredibly similar, since everything can be automated either via kubectl or through the Rancher CLI or through both of those APIs. It's just a matter of tying into the APIs. We should do a master class on Rancher and Kubernetes automation for CI/CD if we haven't already.
Okay, cool. Okay, one more. Does container work on Microsoft on Windows 2016, or do we have to wait for or is there some other version? I think you already answered it.
Yeah,
Windows
yeah.
14.
As long as it's build 14.393 or later.
Yeah, so it should work then on 2016. Okay, I think there are a bunch of questions as you were kind of going through it, but unless there is some new question that I see, I think this would be it.
Awesome. Well, as I mentioned before, go ahead and download the PowerPoint. Look at the various resources. Again, you can get me on Slack. I'm at JVB. I'm on Twitter as Jason Van Brackel. I've put my LinkedIn there. Again, if you hit me up on LinkedIn, just let me know. Hey, I was in your Windows Server Containers talk. This is not recruiter spam, because I get a lot of that. So, and then if you have any questions, by all means, in all of those ways, feel free to reach out to me. It's part of it's part of my passion. It's with what I do with Rancher, my passion of working in the open source community. It's why I run a user group, and I do love teaching and helping level up the people in this industry.
Perfect. Thank you, Jason. We are out of time, but thank you for joining. And please join us next time when we have another topic around security in containers and Kubernetes. Bye-bye.